Hey everybody, this is Larry. This is me doing weekly contest 450. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. It's the most recent contest, well, as of today. I still have a couple that I have to catch up on, but yeah, let me know what you think. And yeah, just no updates, just been tired, so I didn't do it last night. And yeah, my notebook ready, hit all the buttons, and let's go. Let's click on the virtual button. Let's go. 5, 4, 3, 2, 1. Go, 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 go. Okay. Just continue to. Oh, just go to first problem. That's weird. Okay. Oh, this is an actual easy. It's not digits of no, okay, just digits sum, right? Again, sum of the digits of num sub I. Okay, so yeah. We got 2, 1, negative 1. That's not the answer. Oh, you go to I, not sum of I. I was like, I don't get it because it just 2, 1, negative 1. Okay. Silly misreading maybe, but all right, let's go. Sum of the digits seem pretty straightforward. So you sort by minimum number of swaps. That's awkward. I mean, it's an annoying problem. It's a merge sort problem. Classic merge sort. I mean, I thought it was just sorting, but yeah. What you could do with merge sort, you could do with just whatever, right? Let's see. Insertion, maybe. No. Yeah. Okay. Fine. Yeah, it's just annoying. Right. You just count the number of inversion. It's a very well-known problem in general. Wait, is this swaps as in adjacent swaps? What is a swap? Oh, actually, then I'm wrong, maybe. Or at least not this way. I mean, I was like, because some of them is in adjacent swap, right? So then now it's insertion sort. Is it insertion sort or? Well, either insertion sort or selection sort, but either way they're n square, so that's going to be too slow, right? How do I do it then? Well, first we sort, right? I guess that's fine, that part. And the distinct. Okay, distinct makes it a little bit easier. I guess it's just permutation cycle thing. So I think it's just simulation, right? There's nothing to do about it. What's it called? Digit sum and smaller number. Okay. So the sum x and then x, right? We already did this for part 1, but I guess this is easy enough to write. Though maybe I will write it incorrectly this time. Right? Oh, not this. I mean, this is fine, but maybe look up. Today just the problem seems annoying. And then now for okay, so if index we continue, otherwise we have to swap, right? So we swap on the original, right? Now maybe I should have done it the other way. Actually, I think the other way makes more sense for the lookup. Okay, fine. Well, it makes it more intuitive, maybe. Okay, so then now if the result, okay, fine. Otherwise, then we have to swap them into where looks up 2 is, and we do a swap. Oops. Lookup of x, not index. Okay, but then now no, that's fine, I think. Maybe. Maybe. 102. I think this is fine. YOLO. Is it not greedy? Am I missing something? Okay, so okay, so you have this, right? And I'm saying that the answer is 2. Why do I think the answer is 2? Because, okay, first, oh, I'm doing it incorrectly. I did it in the wrong order. Okay, so because I swapped this into the 3rd element instead of the other way around. I need, okay, I got it wrong. Okay, I see. What I need is having this. I need to, yeah, okay, so I did do it wrong. So I do need the nums instead of nums. Yeah, okay. Yeah, maybe I should have printed it. Still wrong. Nums 2 is sorted. Let's double check that it's sorted afterwards. This is not sorted afterwards, so that's not right. Nums 2 is already sorted, right? What am I doing? Okay, slow down. Okay, so we have to look up. This is where we want to. Is that where we want to be? No, that's the original index, and then the sorted order. Oh, well, this is also wrong, even if we wanted to sort it into this. Oh, no, this is the sorted order, I think. Nope. And I'm just being dumb today. Okay, so this is the order, the correct order. We have the lookup table looking like. No, what we want is, okay, I know what I'm doing, but kind of. Apparently not though. Okay, what we want is we want this. So we want to know the index of here. So it's not that we, okay, I think my first idea was more right, but I did it in a dumb way. Okay. So it's not that I want, it's a struggle. I mean, I get it. It's just, okay. But why am I not putting anything? Okay, so I want to get from here to here. So then, but then I iterate on this one. No, so I need to iterate on this one. So nums of 2, with the lookup being on the index, right? Because we want this to be the answer. So then now we go, okay, well, where is this? So then we swap it. Okay, that's just very wrong as well. 204. Or maybe not wrong, but we have to update the index. So then now lookup of x is equal to index. And then what's the previous number? So the nums of lookup of x. Okay, let's just do, okay. Other index is equal to lookup of x, right? Then we swap them. Lookup of, so then now lookup of x is equal to other. And then lookup of nums of other is equal to other. Okay, x, lookup of x is already indexed. Oh no, we want to make that, so that's true. Lookup of the other is the other, right? Maybe. Okay, 1023. I think this is more right. I just kind of really bad at mathing. It might still be wrong, honestly. Okay. Dumb silly Larry. Okay. We have a grid. Each cell is one of the thing, empties, obstacle, or an upper letter thing. We're trying to go from top left to up bottom right. There's a portal. Okay, step. Each portal may use more at most once. Would you? No, you would never do each portal more than once anyway. So I think that's moot because you wouldn't go back. Okay, so it's just buffer search, right? Or that just for buffer search. let's say lookup. Or maybe portal. Okay, all right. Yeah, and then maybe I'll write it here for maybe I could even do better. I can just write and then other right, and then if xy in portal, then we do something. If not, then we set it to that. Otherwise, we then now other of xy is equal to portal of xy, and then other of this is equal to xy, right? Okay, and then now we can buffer search. Where it is buffer? It's all one cost, right? Okay, yeah. On q.append 0 0, right? And then you have times c, just setting it up, right? Okay. Also directions up, down, left, right. Okay. Otherwise, we return -1. So then now, if x is equal to -1 and y is equal to c -1, we return distances of xy. Otherwise, it's just 4dxdy. Yep. Has to be not £. I guess that's it. Was it called grid? Matrix? Ooh. I'm gonna lock my computer by accident. It's not equal to that, then yeah. Then now it could be one of three things. Oh, okay, so matrix nx and y is equal to period, then we just do the normal thing. And distances of nx and y is greater than distances of xy plus 1, and distance update. Wait, does it take one move to go to portal? Or? Instantly, okay. Okay. And then q.append, nx and y, and then we're good, right? Okay, so then now, else if matrix, and now you can't do it. Well, okay. You just write it this way, I guess. It's alpha, and I guess I'll update both. I think that makes sense. Okay, so that's fine. And then we also want to do portal, so then the other way. New x, new y is equal to order of nx and y, right? I think by definition we should already have this, but I think I want to write some asserts, but I am also, I don't know, right? You can also early terminate, but I don't know how I feel about that. Yeah, okay. We have 213. 1100. Why am I not populating it correctly? Portal. Oh, whoops. What did I try to write there? Oh, portal of matrix XY. Okay. Nope. The other. This is portal, but then the other doesn't get triggered. Why doesn't this get triggered? If it is in portal. Oh no. Ugh. Okay. Okay. Wait, where's my print? Auto portal of. Are we done here finally? Okay, 413, is that right? 213. Okay, so I'm not taking the teleport, I guess. Wait, how does this work? So 0 before the first move. Okay, the first move I didn't handle, so that's probably why. That's actually a really bad case for me, but that's good that that was in the case. 13 just doesn't have any teleport, so we want at least one thing that tests teleport. So let's do. So this should save a move, and that should be 3. Okay, that's 3. 4 is no good because we don't teleport. Okay, fine. Okay, fine. So then now, if matrix, it's nice for them to give us that example though. Nope. This is. Two 13.3 sounds okay. YOLO submit. Oh, what? I didn't know that that's possible. Oh, huh. And it's not just 1-to-1, so I would have gotten a wrong answer anyway. But I thought there's only 2. Okay, I just didn't look at the constraints correctly. Okay, what a crappy problem, but okay, fine. No, that's fine. Ironically, the first way I did it would have been maybe okay. I thought there was only one thing, that's why. But, okay. Okay. Well, that's unfortunate. But here, maybe we can write. Oops. Okay, so then what I want is now, yeah, okay, so if alpha, okay, otherwise it's just normal slash I should have already checked. Then now we have for nx and y in portal of matrix xy. And they should all have the same thing anyway, so I think that's fine. Really tricky day today, seems like. A lot of weird things. Am I confident now? I don't know. 1. Okay, so then now we can also have multiple, right? So here. Oh, I have an extra. Is that right? It is right. Okay, YOLO submit. Come on, no wrong answers. Okay, good. Okay, let's not linger. Q4. How am I doing on ranking so far? Ooh, not great. A lot of people got Q4 very quickly. I guess it's I'm doing this quickly, so I guess they haven't removed the cheaters yet. But still. Okay, you're given an undirected tree, so to n-1. Okay, it's a undirected weighted tree. Okay, that's just setting it up. 2D arrays, you have query source destination. Minimum total weight of subtree. Okay, so it's rooted. Is it always rooted at 0? What does this mean? Okay, they're using the definition of subtree. That's a little bit confusing, but maybe that's fine. What is the thing again? 2, 3. So basically, it's just like 0, 2. I mean, it's just like the whatchamacallit. Just combine the trees or whatever, right? Or to combine the paths. This is 7 pointer. How much time do I have left? An hour. And that was a mess. Okay, well, I guess you can't tell anything from people cheating anyway. But and that's why I don't do these live anymore. 0 and 2 to 5. Okay. 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 I mean, binary. Whatchamacallit? Is it binary lifting? Binary lifting is going to get you the 1 query answer, and 2. Is it just? What does getting source 1 to source 2 get you? It should be able to. So okay, so then now you have this. Yeah, okay. I mean, it's just 3 binary lifting queries, right? I mean, I have to write the binary lifting, but I don't think that's that bad. You just do the math. But the visualization is just from source 1 to destination plus source 2 to destination. And then the dupe is source 1 to source 3 or source 2. Right? Minus the. Wait, what? Okay. Draw it again. Okay, so you want this and you want this. So that gives you the duplicate, and then now you have this. So then it's just minus this will give you 2 times whatever. So then now to divide by 2 will give you the extra duplicate part, and then yeah, that's it, right? Okay, not too bad. We'll see. I haven't done binary lifting in a while, so we'll see whether I can actually implement it. But the idea is not that bad. Okay, right. Would it add, say, 0? Or LCA? How do you get distance between two things again? What's it called? Okay. How do I get LCA again in binary lifting? I mean, okay, fine. Okay. Is that the Cartesian traversal or whatever? No, not the Cartesian tree. Maybe, but it's just a depth first. So then the LCA is oh yeah, then you binary, not binary search, but then you walk to determine the thing. Okay, fine. Okay, fine. Okay, yeah. Okay, fine. Something like what's the default value? I guess it doesn't matter. Oh, no. This is the time step. And then we have, what's it called? Time in, time out. I always forget if it's plus n is equal to edges plus 1. Okay, weird spacing now. Right. Yeah, okay. Okay, right. So then now I think that's right, right? Actually, I don't know. It's fine. Go reload. Okay, so there we go. And then now its ancestor is just okay. It's something like no possible ancestor. So it is an answer. Which way does it go? I don't even remember. Return time in of node. So if it's the ancestor, it gets in first and out. Yeah, right. So okay, so time in. Time in. I guess it cannot. I guess it could be equal if it was the same node, which is trivial. Okay, right? Something like that. Though maybe it's more precise to write. No, can that? I guess maybe it's possible. I don't know. I don't think that's. Oh right, yeah. If it's not the same subtree. Okay, fine. Okay. And then now we just do the LCA. Right. So to find the thing, we find LCA, and then path to the root. Okay. Okay, fine. I have to add something to this as well. So that's the distance, right, from the root. I didn't even call it, so maybe I need to call it 0, -1, 0. D, right? So then now distances of node is equal to D. We go D plus W. What's the W? All right, let's see if this runs real quick. Okay, looks okay. I mean, it doesn't crash. I guess I got print stuff. That part I'm not worried about. I mean, this part I've done a billion times, so I've also failed a billion times, so I don't know. Okay, and then now LCA. Node 1, node 2, right? Then now, how do we do it? Oh yeah, okay, so then if potential ancestor, so then return node 2. If node 1, and then this part I always struggle with. Oh. Oh, I didn't pre-process the nodes, right? So, okay. So, okay. How do I write this? Let's just do 20. Is that reasonable? What's 2 to the 18? Maybe I could be a little bit tighter. 2 to the 17. Let's just do 18, right? And then we have I wouldn't go pass. I don't know. Actually, I don't know. Yeah, I guess that makes sense actually. Okay, fine. All right, and then now, I guess here we know the parent. So then here we go. This isn't quite right. I don't want to write it this way. Okay, so parent of, oh man, this is terrible naming. Okay, fine. Parents of 0 of node is equal to node, so that's 0 steps. No, that's 1. Let's keep it 1 step. Right, so then this is parent. And then for I in range of m, starting going to 1, and parent sub I of node is equal to parents I minus 1 of node, and then this gives me the node, so then okay, something like that, right? Okay, print parents. Okay, that's why I want to run it. What? Not none type. Oh, it's none. Okay, so we don't set it up for 0. That's why. No, it's 0. Oh, because it's just -1. Yeah, which is true. That should be fine. Oh, because then this is -1 as a reason, or something like that. Oh, this is well, okay, one of them is -1. I see. How do I want to write that? I just want to set it to the root, right? So I don't know if this comes back to bite me if I just choose 0. But I guess for now it's fine. Okay, so no, that's okay. So that's the parent on the 0th level. 2, 3, 4, and then 2. Okay, and then this is 2 steps. It's 1, and then the next one should be 0. Okay, I think this is right-ish. Okay. It's been a while. I guess people have templates for this, but it is what it is. Okay, so then now we. Okay, so for I in range from m -1 -1 to 3, right? So then now we go. Okay, if parent sub I of node 1. This doesn't really matter, right? Node 1. If something like this, what does that mean? So that means if the root is an ancestor. Okay, so but we want the opposite of that. So if this is not an ancestor, then we travel, right? So okay, so then now node 1 is equal to okay, right? So then now if it is, then you don't travel. Right now we turn node 1 or parent of node 1. Man, I should have template for this. Okay, we can print out some quick ones. Okay, let's see. 2 and 3, say, and then maybe 2 and 5, 2, 5, 4, 5. All right. I mean, it's going to be 1 time error, so 0 is the root for 2 and 3. That's not right. There should be 1, 2, 5. It's 2. That's right, but that's I think a default thing here. And then 4, 5 is 0 is also not right. So Okay, let me think. Okay, so how much time do I have left? 46 minutes. That's fine. Okay, so I'm debugging people code that people have template for is a little bit sad. Okay, so it's if this is not the ancestor with this step, we have to get it. Okay, that's fine. Okay. Yeah, that's fine. So then, what if it is? Okay, if it is, then we don't. So we go back. So we find the one, maybe. But I want to say maybe it's this, but I don't see how that would change anything because it's just zeros, right? So there's something wrong here. Did I set this up wrong? No. 1, right? This is so annoying. Node 1, node 2. parents I node 1. I guess it doesn't really help if I don't print out the result. Okay, so the zeros, what am I putting? Between 2 and 3. 2 and 3. Parents. Okay, so it thinks it's false. That's why, and it goes to 0. So the false part is really wrong. But why is 0 false? Oh, I did it the other way, I think. Okay. Because, yeah, okay, fine. 2 to 4. Okay, then now I think this is more reasonable to be this. I thought maybe it's that, because you want to get the last one that isn't that. But yeah, 1, 2, 1, okay. Now we're Gucci, I think. Okay, so then now we can do the math. Okay, so then now distance between 2 nodes, what is it? It's going to be equal to okay, LCA is of node 1, node 2. So maybe, I don't know. So then now we have what do you call distances? So yeah, it's going to be return distances of node 1 plus distances of node 2. This double counts distances of meet, and then there you go, right? So then now we can get distances from, oh, we have to enter the queries. I forgot that we have queries, it's not just one. Okay, how the query structured? Okay, for I don't know, whatever. S1, S2, D destination in queries. Okay, we want to say, I don't know, whatever for now. This distances from S1. I think we're close now. I guess that's, I mean, I think even if you have templates, if you had templates, I could see how anyone get this pretty quickly. Okay, so 9 and 11, is that right? S1 to S2. What's the query? 2 to 3, 2 to 4 is 7. That's not right. 3 to 4 is 9. Maybe not right. Why is that? Okay, S1. Just making sure that I'm looking at the right thing. Okay, 2 to 4 is not. Oh. 2 to 4 is 9. That's not right. Okay, so then here, then 2. Okay, so we want to go from 2 to 4. Distance is 5 and 6, is that right? 5 and 6, that's right. And then meet is going to be, they meet at 1. Distance 1 is 2. So then now, oh, distance from 2 to 4 is not 2. It's going to be 2 times that. Okay, because it's not, I've confused the problems. Okay, fine. I see. So yeah, 7, 9, 0, 5 is the 11. That just makes sense. 2, 5 is 6. 2, where's the 5? Oh, 6, yeah, okay. Okay, so then now I feel like this is right. And then now we have these two distances. D1, D2 is equal distance, S2, right? And then now if you sum up together, you would double count the overlap. And the overlap is just Huh. It's not the LCA, though it is similar in idea. Oh no. You did this. You did the math. Okay, so then the overlap is 2 times the overlap is equal to the distance from S1 to S2. No, this is not overlap, but direct maybe. Okay. I'm looking at my notebook in case anyone's curious, because I drew this out. So then now, so if you sum it, then you have that, and then the overlap is the direct. So then the overlap is equal to D1 plus D2 minus direct over 2. This part the part that feels weird is that this has to be even, so which would be weird for this problem, I think so. But it's a little given the constraints, but it feels awkward that that's the case. So let's run it real quick. I guess that looks right. Okay, so then now it's just minus overlap once, and then that's it, right? 12, 11, and 15. Okay. I mean, definitely possible that we're making a silliness somewhere, but I feel like this is okay. So let's give a YOLO submit. Okay. Whew. Yeah, I mean, I don't think it was a tough problem. It was just, like, it's very templateable. If I had templates, it probably honestly is like a 5-minute problem for Q4, even without ChatGPT. But yeah, 233 is fine. I don't know. I mean, there's a lot of cheaters, right? So I don't even know what my real rank is anymore. But I'm happy about this performance. Yeah, let me screenshot it and post it on the Discord real quick. But yeah, this is 450, right? Okay, yeah. Yeah, I mean, I don't have any comment on this one, I don't think. Q3 was actually slightly harder. Why is that? Oh, no, that wasn't harder. It was just silly mistakes. Q2, I spent the most in Q2 because I just misread this one a little bit. And also I just got confused with the swapping. That's just silly. But overall, like a pretty standard, straightforward contest, I think. Even Q4 is... okay, maybe not. Actually, Q4 requires a lot of specific knowledge. Once you have that knowledge, it's straightforward, but... So I don't know if I like Q4 for that reason. Because if you have a template, then it's like a 5-minute problem, I think. Because for this one, I think all this is template, or all this is template. And then I don't know if this is template, but you can come up with it pretty quickly in 5 minutes, like I said. So like as soon as I drew it out, you know, and I have it in the explanation probably. As soon as I drew it out, it was pretty reasonable. But yeah. Anyway, that's all I have with this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.